Welcome to the British Waterways Bulbourne Workshops. This lock-making facility has existed on this site near Tring in Hertfordshire since canals were first introduced in the early part of the 19th century. Much of the machinery in the early days was driven by steam, and the water tower, which is an attractive feature of the central building, was used to service the two boilers which provided power for the workshops. Some of the old pulleys and belts can still be seen, though are no longer in use. We are going to take you on a tour through the workshops and introduce you to the many procedures, processes, skills and trades which combine in the making of lock gates. Unseasoned English oak is secured from forests all over the country by the timbermen and is supplied pre-cut to dimensions specific to a particular lock gate. This minimises the amount of wood waste and machining required at the workshop. All locks are different. Some have a greater fall of water than others. Some are wider and some have a different batter. The batter is where, instead of the lock walls being vertical, they are slightly angled. This batter can change with age as the lock foundations settle or move. As a consequence of this, each lock has to be measured and the gates exactly tailored to fit the lock walls. To ensure this, all gates are carefully made to engineering drawings. Many of the manufacturing techniques and crafts used at Bulbourne still date back to the time of the first gates 200 years ago, but in many cases power tools and machinery have replaced the effort needed with the original hand tools used by craftsmen of that era. Timbers and planking are planed to size to ensure straightness and remove any wood defects. Straightness of the timbers and planks is vital to provide strength in the gates and ensure good watertight ceiling faces. The planing machine is one of the original machines powered by steam, but has been upgraded and now provides a safe and efficient tool for modern use. Once planed to size, the timbers are marked out to show the areas where wood is to be removed to make the mortise and tenon joints. Mortise and tenon joints are the means by which the gate bars are slotted into the upright posts called hill and breast posts to give the necessary strength to the structure. The hill post is the rounded beam which is in contact with the lock wall and acts as the hinge of the gate. The breast post is at the other end of the gate and acts as the ceiling face with either the opposite wall or the other gate. The post timbers are placed on the mortise machine to have the rectangular mortise holes cut. The mortise tool is a combination of a four-sided chisel with a drill running inside to remove the bulk of the wood. Holes are also drilled through the heel and breast posts to accept the tie bar. This is an iron bar threaded at each end which passes through the width of the assembled gate and is tightened to add strength and ensure beams and posts are held firmly during the gluing process. The tenon machine, seen here, produces the matching tenon joints that fit into the mortise holes. The heel post is carefully tapered along its length from the planer to exactly match the batter of the lock walls. A radius is carefully machined along the length of the heel post. This will act as the hinge of the gate when fitted to the lock. Traditional hand methods such as hand planing, chiselling and draw planing are still employed for fine adjustments and final fitting. Iron hoops are fitted at each end of the heel and breast posts to prevent the wood from splitting. The wood is carefully recessed to give a tight fit. Final hand adjustment is made to the collar hole. When fitted to the lock, the gate is secured by using an iron collar. This passes through the collar hole in the gate and is secured to the top of the lock wall. A tenon joint is hand produced on the top of the heel post to accept the balance beam, which is assembled after the gate is fitted to the lock. The heel and breast posts are fastened to the gate bars using circular oak pegs called draw pins. These are handmade for maximum strength by ensuring the grain of the wood runs along the length of the pin. The finished heel and breast posts are offered up to the gate bars ready for assembly. Glue is applied to the mortise and tenon joints. The posts are then assembled and secured using the iron tie bars that pass through the width of the gate. Finally, the oak draw pins are inserted to firmly secure the heel and breast posts to the gate bars. Glue is applied to the gate bars and the pressure planks are assembled into place. These seal the gates against water leakage and are machined to give a very tight fit. The last board is gently eased into place. These are then secured using galvanised nails. The pivot on which the gate hinges is called the pintle. A hole is drilled in the base of the heel post, and this is then shaped to accept the tapered shank of the pintle. The pintle is driven into position. This will support the entire weight of the lock gate and the balance beam. The joints between the heel and breast posts and the gate bars are strengthened using iron brackets commonly known as L's and T's because of their shape. Recesses are cut into the wood to locate these, and a pattern is used to guide the router, ensuring an exact fit. The L's and T's are positioned in place and fastened with bolts. Metal fits are cut to size and welded in situ. This provides the sealing face between the lock and gate. Final trimming and tidying is carried out before the finished gate is ready for removal to storage. As the oak is unseasoned, it is important that it doesn't dry out, as shrinkage and cracking will occur. This would result in the gate leaking once installed. To prevent this, the gates are stored either underwater or kept continually dampened by regular spraying. Paddles and paddle gearing are an important part of lockgate manufacture, as this is the means by which water is controlled through the locks. The majority of paddle gearing components are made from cast iron. These are supplied from the foundry using existing waterways patterns. Critical faces and surfaces on the rough castings are machined to give precise dimensions in accordance with engineering drawings. Once machined, the various paddle gear castings are assembled and fitted to the paddle post. The paddle posts are made from the hardwood Opepi. This has less tendency to split than oak when in dry conditions. The rack in this top gate gearing is fitted with great care to ensure free running of the mechanism. Top lock gates have small paddles, whilst bottom gates have much bigger and heavier paddles. The gearing on the bottom gate, therefore, has a much higher ratio. The gearing on this bottom gate mechanism is also checked for smooth and free operation. Finally, the mechanism is greased and is then ready for assembly to one of the gates. Bulbourne Workshops also has a well-equipped fabrication shop. Here, gates from a composite of steel and wood are made, along with steel balance beams and a variety of lock gate furniture. Steel is normally delivered cut to size, but in some cases, such as this special heritage balance beam, sections are specially fabricated. Balance beams are now made in box sections, and as the name suggests, they act as the counterbalance for the weight of the gate. A compartment at the wider end of the gate is included to enable heavy material such as scrap iron or concrete to be added. This allows for precise balancing of the gate on installation. Although there are arc welding and gas welding facilities, the majority of production is carried out using MIG welding. This technique allows for a high quality weld combined with the speed necessary for modern production schedules. The pre-cut sections of the beam are clamped into place and initially stitch welded to reduce the risk of distortion. Once stitching has been completed, the metal joints are seam welded together. The body of composite gates consists of two upright steel channels into which oak hills and breasts are later fitted. Box section cross members are then prepared and welded to the upright sections. As with the balance beam, these are first stitch welded to prevent distortion. As the gates are being made, the paddle and frame assemblies are also being fabricated. Originally made from beech, these are now made from a plastic material supported on iron frames. The completed welds on this main structure are cleaned and prepared for the steel sheet which seals the gates. hole is cut which allows water to pass through the gate once the paddle is fitted. On completion, a protective coating is applied to all metal surfaces. These two gates should have a life expectancy in excess of 25 years.
Steve? Yes, I'm fine, thank you. And you? Good. This is to let you know that Duke's Cut and Shipton Weir gates have just gone out of the yard now. So, you know how long it usually takes. Yeah, it's the usual driver as well. Okay, bye.